The second part of level 3 will be determining whether a function has even symmetry, odd symmetry, or neither. And we can determine this from a graph or from an equation algebraically. So first we're going to kind of talk about the definition. For a function to be even, if there is a point on the graph, x, y, then the point negative xy must also be on the graph. So any xy pair should also have a negative xy on the graph. What that means, if we look down at this picture, this first one is an even function. Let's say this point right here is the point 2, 5. Then the point negative 2, 5 should also be on the graph, which it is. So that's what the definition of even symmetry is. And then also from a graph, even is the easier one to identify because it's symmetrical about the y-axis. Jot that down. Symmetrical over the y-axis, which means that the y-axis is the line of symmetry for the graph. And if you look at this first graph, this parabola, the y-axis goes right down the middle. It's a line of symmetry. So that's an even function. Now an odd function, if you have any point x, y on the graph, then the point negative x, negative y must also be on the graph. If we look at this middle graph down here, which is an odd function, again, we're kind of estimating, but let's say this is the point 2, 3. The point negative 2, negative 3 must also be on the graph, which it is, negative 2, negative 3. So for any point on the graph, you must also find the opposite x and the opposite y as a point as well. And in terms of symmetry, an odd function is symmetrical about the origin. Now, how could something be symmetrical about the origin? Here's kind of what that means. Imagine if you stuck a pin right in the origin, which is the point 0, 0, and then you rotate the graph 180 degrees. Would it land right in the same place? Yes, it would. So that's what it means to be symmetrical about the origin. If you rotate it 180 degrees about the origin and it lands right on top of itself, then it's an odd function. Now, if you look at the next graph, it looks very similar to the odd function that we just had, but if I stuck a pin right in the origin, which is down here, and I rotate this graph 180 degrees, it's not going to land in the same place because it's shifted up. And also, if you look at the point, let's say this is the point 2, 4, well, that point is not on this graph. This point, which would correspond to it, is negative 2, say negative 2. Close enough. So we didn't have negative 2, negative 4 on the graph. So that's not an odd function. So some functions are even, some are odd, and many are neither. Now to tell if a function is even, odd, or neither algebraically, we're going to use this definition. And basically what we're going to do is if we plug negative x into a function and we get the exact original function back, then it's even. If we plug negative x into a function and we get a negative version of the function, then it's odd. So let's look at these examples down here and we'll talk about what that looks like. So to determine algebraically if a function is even, odd, or neither, you're going to find f of negative x. So you're going to plug negative x into the function. So for this one we get negative x squared plus 1. Now, when I square negative x, I get positive x squared plus 1, which was the exact function I started with. And when that happens, you have an even function. Okay, let's take a look at this next example. Again, same test, we plug in negative x to the function. So if we plug in negative x here, negative x to the third minus negative x. Negative x to the third power, whenever you have an odd power, you do get a negative, so this is going to be negative x to the third. And when I subtract negative x, I get plus x. Now, this function, every single term in this function, which is only two terms, changed to its opposite. So this is really the same as negative x to the third minus x, which is the exact negative version of this. So this is an odd function. If every term changes to its opposite, or you have f of negative x equals negative f of x, then it's odd. Whereas even, you plug in f of negative x and you get f of x back, which you started with. Okay, now let's take a look at this last one. Again, same test, plug in negative x. We get negative x to the third minus negative x plus 1. And negative x to the third is negative x to the third plus x plus 1. Now in this function, the first term changed to its opposite, the second term changed to its opposite, but the last term stayed the same. So this would be neither. To be even or odd, you either need your whole function to stay exactly the same, or you need the whole function to be the opposite. And if that doesn't happen, it's neither.